Hello, my radical pre-calculus class. We are ready for another online adventure. Today, we are going to talk about inverse trigonometric functions. We use inverse trigonometric functions when we're looking for an angle measurement. Again, when we're looking for an angle measurement. You're going to be allowed to use your unit circle. So let's look at this unit circle again. Remember, on the inside, going counterclockwise, we have the positive angles. On the exterior, going clockwise, we have the negative angles. Also, when you're looking at a unit circle, remember that the y-coordinate is the sine, the x-coordinate is the cosine, and tangent is the sine divided by the cosine. When we have a trigonometric function, the domain will be the angle measure, and the range will be the ratio. Here's like a little template. The sine of the angle measure equals the ratio. So we have here the sine of 30 degrees is equal to a half. So here's the angle measure, here's the ratio. We could take that 30 degrees and change it into radians in terms of pi. So we can say that the sine of pi over 6 is equal to a half. And if you look here, inverse sine, we're looking for an angle whose sine is a half. You see in the first quadrant is positive. We're just looking in the first quadrant. Inverse sine is positive a half, and you see that's 30 degrees, which is pi over 6. When we do our inverse trig functions, we interchange the x and the y. The domain becomes the ratio, the range becomes the angle measure. Here's a little template. See, it's inverse sine. We raise the sign to the -1. It's read inverse sine of the ratio is equal to the angle measure. You see this time, here's an angle and the ratio rather, and then we're looking for the angle whose sine is a half. We're looking for the angle whose sine is a half. We're looking for the angle whose sine is a half. This is another way for writing inverse sine, arc sine. So again, we have here that the angle whose sine is a half is pi over 6, 30 degrees. Make a note, please, that inverse sine of x is read. You see inverse sine of x, sine of the -1 of x, it's always read inverse sine of x. And another name for inverse sine of x will be arc sine. So you could say instead of inverse sine of x, you could just say arc sine, which is the very same thing. And also remember that sine of the -1 of x does not mean 1 over sine of x. It's cosecant of x is equal to what? 1 over the sine of x. Here I sketched two cycles of the sine function to indicate the vertical line test and the horizontal line test. The vertical line test says draw any vertical line. If it touches the graph at only one point, it is a function. So sine is a function. The horizontal line test, draw any horizontal line. If it touches the graph at one point, then that graph has an inverse. Well, look, you see this horizontal line, the x-axis? 1, 2, 3, 4, 5 places it's touching. So this function, y equals sine of x, does not have an inverse. Well, how are we going to talk about inverse trig functions? What we're going to do, we're going to chop that sine curve off from negative pi over 2 to a positive pi over 2. And when we do that, we have something like this. See our inverse sine function now. So the domain is from -1 to 1, and the range is from negative pi over 2 to pi over 2 for the inverse sine function. Here's a quick review also of a smart trig class, which reminds us which trig functions are positive in which quadrants. In the first quadrant, all the functions are positive. In the second quadrant, only sine and its reciprocal cosecant are positive. The other four will be negative. In the third quadrant, just tangent and its reciprocal function cotangent will be positive. In the fourth quadrant, just cosine and its reciprocal function will be positive. So that was a quick review of that. And when we are doing our inverse trig functions, see inverse sine of x, if this x, the x is a ratio, if it's a positive number, then we're going to get an answer. Since we're talking about functions now, we will always get an answer in the first quadrant between 0 radians and pi over 2 radians, or 0 radians and 1.571 radians. If this ratio is negative, the calculator or our answer will always give us something that's in the fourth quadrant, and we're moving this time clockwise, so it's going to be negative. So let's look at that again. Here's the first quadrant. You see, look inside of here. These angles are positive. Here's the fourth quadrant, moving clockwise, but you're going to be looking at the angles on the outside, and they're negative. So here are some examples. We're going to be using our, well, let me move this out of the way. We're going to be using our calculator to do this because, see, this is a ratio, but it's not on the unit circle. So we hit second sign, and then you're going to type this in, and you're going to get approximately this. Here's the ratio, here's the angle. This is positive, and we are in quadrant 1. You see positive in quadrant 1. You see 1.3 is between 0 and 1.5 there. And here we can check it. We take the angle, take the sign of the angle, and we're going to get the ratio approximately. Let's look at another example. Here, if we have inverse tan of a negative 6, here's the ratio and here's the angle. The ratio is negative, and we're getting something in the fourth quadrant. So let's look at that. You see, fourth quadrant between 0 and a negative pi over 2, which is between 0 and a negative 1.571. Well, negative 1.4 is between what? Between 0 and a negative 1.5. So this is what I'm saying. The ratio is negative. We get an answer in the fourth quadrant. This is how we can check it. We take the tan of the angle, which is approximately the ratio. Let's look at a third example. Here we have inverse cosecant of a negative 5 over 2. Well, most of your calculators don't have inverse cosecant, so we have to think about reciprocals. An angle whose cosecant is negative 5 over 2 is the same angle whose sine is the reciprocal, which is a negative 2/5. And when we put this into our calculator, we're getting approximately negative 0.4115. This is the ratio, and this is the angle. It is negative, and it's in quadrant 4. It's negative, and it's in quadrant 4 from what we were doing. And here, we can check this, the cosecant of the angle. Well, again, the cosecant is not on the calculator, so we have to think of reciprocal functions. So what we're going to have here is that cosecant of negative 0.4115 is equal to 1 over the sine of this angle, which is approximately negative 5 over 2. Now, we've gone through quite a bit, but you know what you have to do. You have to stop, rewind, and review. Stop, rewind, and review. My love going out to you.